This video introduces a TRINITY use case demonstration, artificial intelligence-based stereo vision system for object detection, recognition, classification, and pickup by robotic arm. In this video, we will present what are the benefits of our TRINITY solution and how it contributes to agile manufacturing, implementation and application scenarios, what kind of investments are needed, and finally, we would like to conclude this video by emphasizing the possible benefits of this TRINITY solution. Traditionally, working with randomly distributed objects requires human resources or dedicated sorting hardware that usually is spacious, expensive, and hardly adjustable if product assortment changes. The problem becomes more complex if different kinds of objects are mixed in one pile and needs to be sorted and structured into determined position and orientation. The proposed AI-based stereo vision system can be trained to detect and estimate the pose of different objects that are randomly distributed in a pile, therefore enabling automation of industrial processes involving a different kind of objects with unpredictable positions. It has been developed with a focus on this particular scenario, where bottles and cans are being sorted. However, the use case and its modules can be adjusted to different scenarios and different industries. Implementation and application scenarios. This solution consists of three modules: object detection, object classification, and robot control module. The combination of these modules is shown in this TRINITY demonstration, where different kinds of objects are being sorted and placed in determined position and orientation. The solution has been built upon the robot operating system. The modules are structured as robot operating system packages that can be used separately in different application scenarios. For example, object classification module can be used in simpler tasks where just a type of object needs to be determined and potentially could be applied in object sorting process or assuring that the right type of object has been put in the particular machine. As in other OpenCall, one external demonstrator where different electromotor stator are being classified. The usage of ROS ensures compatibility with different kinds of robots and depth sensors, therefore easing the implementation into different devices. For example, the system has been tested with different ROS-supported 3D cameras, such as Kinect, Intel RealSense, and Zivit. Investments. Bare minimum hardware that is necessary to run presented modules is industrial robot with a gripper, vacuum gripper or parallel gripper, RGBD cameras, and robot operating system PC with a modern graphics card. Hardware costs respectively depend on industrial robot, camera, and gripper types and brands. The hardware that is used in these modules costs approximately 30,000 euros. Conclusions. Proposed TRINITY AI-based computer vision system can improve flexibility, quality, and reduce costs in different manufacturing processes. The system provides functionality that enables to automate tasks that traditionally requires human resources or spacious and expensive equipment. If you got interested and would like to find out more, see the following training material describing the system in more detail or contact us. Thank you for watching this TRINITY use case introduction.